Hi, everyone. Thank you for coming. This is amazing. A lot of people. I'm very happy to see that people are interested in this talk. My name is Diego Morales, and I am an ex practice lead at Watercare, as you guys see there. I just moved to another role in a different company, but I will still come to represent my ex-employee. Which is great. So today I am actually going to take you through a journey of how at my time at Watercare we implemented a new modern data stack. The problems that we face, the challenges we had, and the things that we did. That, in a way, like everybody here is so talented and technically gifted. So I'm not expecting to tell you like the most crazy technical thing, but how we did it, and what worked for us, what didn't, that kind of stuff. Um, all right. Clicker, no, here we go. All right, so as I say, my name is Diego. I am a Chilean, and I'm actually an industrial engineer. That was what I did at university, and I keep saying that the one skill that I got out of university that I value the most was the ability to use an engineering mindset to break a problem into little pieces and trying to solve a challenge. I think that's probably the one skill that I kind of treasure the most of my time at university. I'm also a jazz musician and a Latin music enthusiast. I love music, and so in this presentation, apart from taking you through the technical kind of stuff and showing you a little bit of what we did, I'm also going to draw a parallel between jazz music and analytics. So I hope that's interesting. I kind of have the feeling that they have a lot in common, and I kind of want to put my 2 cents on that. Um, so the beginning of the journey at Watercare happens basically because Watercare was rolling out smart meters. In the electricity world, you can go in your app and you see how much electricity you're consuming. For water is very similar. Now that's kind of like the objective on the long term, right? Your mechanical meter, but now you got this electronic unit that sends some packages every 10 minutes. And obviously they just have limitations too, right? Like they're not constantly connected to electricity, so hence send packages of data every 10 minutes to kind of try to maintain the battery life for a longer time. So the numbers of water meters installed per year in Auckland, it went increasing, massively every year. There are more new houses, there are new water meters, and there's more data coming every day. At the time that I designed this presentation, it was just about 4% of the operational smart meters, but now it's like 12%. So it's growing, and it's growing really big. I didn't get to mention about Watercare, but Watercare essentially is the biggest water service provider in all of New Zealand, and now it's probably going to get bigger because there is a water reform happening in New Zealand. So it's basically tons and tons of data. That's a smart meter. Essentially, this unit is connected to your pipe, and it measures, and it's got different kind of measures, right? Temperature, pressure. Is there a leakage in the pipe? Is the pressure in the pipe had dropped? And it's got all these kind of different features that is trying to show you if there is any anomaly happening. Which obviously, this for us and for me when I joined Watercare was like, well, this is a perfect use case, right? Because here we got granular data, 10 minutes packages, and can enable analytics, but as well as machine learning models, because now we got some more smart little insights that we can get. Is there a water meter that has been tampered with? Is there any anomaly in the consumption patterns? Customers want to know if they have a leak in their system and stuff like that. So it became quickly like the one use case that had the quality of the data we needed to roll out a full-on new data stack. And that's how we went, okay, we should probably look at dbt because it looks like it's a tool that everybody's using, so it must be for a reason. So the need for a framework to accelerate data modeling happened because obviously, as I mentioned, the data was growing massively, and well, the business wants some operational reporting, right? So they were like, well, how do we do it? And we got challenges. The schemas can evolve and change. They send JSON packages, and JSON, it's not a format of data that has a schema, so it can change at any moment. And we needed to find a way that we could deliver this reporting at the end, but at the same time translate it into something that we could manage and it wouldn't spiral out of control. This part is what I call the I want doesn't get, and this is funny because I mentioned it to my stakeholders when we just put the idea out that So if you want analytics, there is different kind of analytics, right? Some of these one will have a likelihood that will change, and some of these may not change. And then also the feasibility of recreating or doing this analysis with a data model can change, and it varies depending upon the use case. And with this, I kind of try to show the correlation between these two factors in the equation. So over the last few months, Watercare didn't just go for the use case of a smart meter. In fact, went even further because they saw how effective the new method was and the new framework that they were like, okay, let's go only for customer billing, finance, and work order. So from like a 20 models kind of project, it became a 150, 200 model project within the span of 12 months. So similar here for finance analytics. You know, there is some kind of analytics that they are very likely that are going to change. In finance, it's kind of a little bit more static though. But when you get things like, for example, work orders, by work order, we're talking about that they're contractors that come to Watercare and they get the order and they go out and do the jobs in the field. Like, you know, they have to fix a pipe or they have to change a water meter and many other things that happen within the realm of the water services industry. So if you want something like, for example, work orders viewed by type, department, trade, age, you know, there is a likelihood that once a new person comes with a new operational mindset, they're going to say, actually, I need to change that. If I need a new kind of analytics, if you don't have a data model, well, likelihood is that you won't be able to produce that very effectively, and then you're going to find yourself in the normal case that you build and store procedures to produce one analytic and then another one, and then spirals out of control, and then you end up with a super massive squid of data models. So overall, what this is about is that more complex reports have lower feasibility without a data model. The reports tied to evolving operations have a higher change likelihood. That simplistic, stable reports are less prone to change, and flexible data models critical for complex multidimensional reporting, as well as agile modeling enables adapting to changing information needs. This is kind of self-explanatory, but when you're in the data world, this is pretty obvious for us. But when you're talking to stakeholders, you had kind of got to put it in this language. For them, it's all about, you know, what's the return over my investment of this, and why do I need to take this operational decision? So this whole picture was very good to talk to stakeholders with, and they got convinced that, okay, we should go for this because this framework seems to prove itself in these terms. So that was about Watercare and how we went into this journey. So what I want to talk about is that how DBT, Snowflake, and in our case, Azure DevOps, became our little jazz band at Watercare. You know, as my, it's interesting because someone here just talked about music too, and it's big coincidence because like for me it's big part of what I do. You know, the creativity side, which I think is probably in all of you when you sit with your data and you're trying to find creative ways. In a way, the analytics engineer, the data analysts, the data modelers are very similar in this matter, right? You have a set of rules that you want to play with, and then create something that you can reproduce, and you feel like you are improvising over this sometimes and creating something bigger than the sum of its parts. So in that matter, the analysis that I make is that DBT is the instrument in the data analytics jazz band. Snowflake for us was the stage, and Azure DevOps is where we iterate and organize the evolutions of these songs ideas. And what do I mean by this? So, well, why data analytics is like jazz? Well, data analytics and jazz, you know, might seem like two different disciplines, but they actually have a lot in common. Improvisation, collaboration, creativity, and structural rules are big parts of what jazz music is, and how when you are, you know, in a jam session, how the things work. Jazz kind of sounds sometimes like it's all over the place, but actually there is a lot of structures and rules underneath. So the first point, what is jazz improvisation and how does it link to analytics? So improvisation in jazz is basically the art of spontaneously creating new melodies, harmonies, and rhythms, and other musical elements within a framework. And what you see here, it's basically the chord sheet of just standard chord, all the things you are. You got your chords, and then you improvise over these chords, and you follow the changes, and you kind of create music over this. So why do I feel like this is similar to what DVT, in the way that DVT worked for us? So we were able to quickly prototype, or in a way improvise. It was much harder before if you work with SQL Server and stored procedures to try to put an idea together, because you spend more time building the stored procedure than when you were actually building some piece of analytics. With DBT, that was gone. And what I'm trying to show here is that this is kind of what we had before when I joined Watercare. This was supposed to be a DAG of different data models. Very hard to read, right? Like the complexity of this definitely does not encourage anybody to use it. And the business analysts that put this together, probably now all the time that I put to create this is now going to go to waste. And this is another of the different data models that we had. Obviously, this thing, it's a PDF. Who can utilize this for? What would you use it for? It's obviously not going to help in anything. That quickly really became evident once we had DBT, and this is not working. Here we go. Quickly became evident for us, because even though, like, we had a session earlier before when they showed this gigantic DAG, but you can navigate through it, and that's like, it's obviously a big game changer for someone that's trying to encourage self-service analytics, because now you can take your documentation, you can put it in a website, and then you can navigate through it, and that obviously makes a big difference for stakeholders to get engaged. And this was a little bit of like, trying to show, this presentation was created, I guess initially not thinking about all of you have seen how the DAG works, so obviously you've seen this like a million times. But yeah, I guess the navigation component in the DAG, it was a game changer to encourage people that we're creating here a piece of data warehouse for self-service analytics, and you can navigate through it and not get confused. Also, DBT commands enabled us to separate these ideas in code and test all of them in a unified orchestration. Now, you don't have to build a stored procedure to now orchestrate the other stored procedures, which is what happened in the past. Now, it just happened everything in a unified orchestration. Easily we were able to, understand the code and identify where things are not working as expected. And obviously, for debugging, that improves massively, right? Here we go. This is one of the patterns that we sort of came up with. Dev schemas, obviously very standard in DBT, but the pull request schemas was a little innovation and improvisation that we sort of came up with. An idea that here now the QA environment is generally seen as like, you have a copy of production, but we decided to go a different way. So we created a QA database which would only contain the elements that were needed to build your pull request. So now all of the testing, and the specific elements will happen, and they will spin up in this new schema, and once the pull request gets approved, it goes away. There's space for improvement in this, like for example, doing a zero copy clone, so that you don't consume the data from production environment and stuff like that. But at the time that we came up with this idea and they sort of like put it forward to people that do testing, for them was like amazing, right? Because now they have like productionized data, creating a complete different environment, and then it goes away, there is no risk. So for them, it was something like, they saw that as a big advantage. Here we go. Now, the other element is collaboration in Jazz. And this, I think, is, most of you that work with your teams can see how this relates back to analytics engineering and to data analysts, right? The collaboration in Jazz, it's the main aspect of the music. The idea is that you're there with the other musicians, and then you improvise, and there is this sort of underlying communication happening between the musicians that if you're in the audience, you might not be able to notice, but when you are like locked in the groove, you know what's happening, and it happens very similar to teams of analytics, right? You don't have to say everything. There is this unspoken things that you manage with your team, and it becomes very obvious, which happens also in jam sessions when you're jamming with other musicians. Um, so collaboration, obviously, DevOps and the Git approach, it's where everything happens, right? So it's interesting because I think that for most people that they work with dbt, I think the Git component and the CI/CD pipeline, it's the one thing that sort of like stood up as like a big difference of like how we used to work in the past, or at least in my experience, and how this can improve. Having this sort of like unified workflow of cohesion and with like different ideas coalesce into a single piece of code at the end. And to proof of that, like we started this proof of concept in September last year, and now by September of the next year, we already deployed every single piece of model that we got given funding to build. And we're talking about 200 models. So, I've like in terms of comparison and benchmarks to like projects how you will work in the past, this is like massive productivity boost. All of a sudden, you could get rid of your legacy systems because now we got productionized models that can allow you for self-service, and everything happens in 12 months. That's pretty remarkable. And that's just showing a little bit more of how we manage, the pull requests and the different patterns that we kind of came up with in our project. In Watercare, the analytics vision was to build a data warehouse with a focus on self-service. So for us, it was like, well, we need a solution that we don't have to build documentation. And obviously, DBT, I think that completely excels in that, right? Like, documentation happens just as you code comes up, and then you can take it anywhere you want, and anybody can see it, right? Like, if you're a technical person, if you're a non-technical person, you can take advantage of this and then get related to it. At my time at Watercare, I always advocated for more and more people getting access to SQL and not just utilizing Power BI, because I feel like, at least my point of view is that if you have a safe sort of sandbox environment, people should have the opportunity to come and mess up with the data. Even if they build queries that might not be, performant, they still should have the opportunity. And we were trying to encourage users to do that by exposing this documentation to them and letting them, trace the lineage of the data. The other concept here, and I feel like this is probably the one thing for me that it's the most remarkable thing about DBT, which is the community approach. And here there is an example of, at Watercare, we, even though we use cloud databases, we use Snowflake for our provider, we enforce referential integrity. I'm a big advocate of Kimball methodologies, and I feel like they're more relevant than ever before, even though I know there is a lot of people in the folks community, in the analytics community, that will say that, data modeling is changing, one big table or whatever approach is now coming up. I believe that dimensional modeling and Kimball methodologies are more relevant than ever before. Because this data warehouse was with a focus on self-service, we wanted to have the opportunity for people to have the complete data model with, seeing all the keys and see how it connected. So we wanted all our tables to have primary keys, all our tables to have referential integrity if they have any connection with any model. And to do that, we use a package called dbt constraints. An interesting thing, we found a bug in the package. We posted it in GitHub, and within a day, it was solved. That, to me, is the one thing that it's the game changer in this whole thing. Even, CI/CD and everything is great, but the fact that you're not locked into logging a service request ticket and having to wait for a week, here you have a community. And the community approach, it's like what I believe makes a difference. So we also implemented data freshness to all our sources, and we collaborated with data engineers every day to tell them, hey, look, this data is still, we have to have a look at what's happening with this pipeline, because we have no visibility of that before. Next element is the creativity in jazz, and here there is a photo of my son getting involved with music. He loves banging on those drums and playing the piano. Now he's really obsessed with Happy Birthday. He sings it every day. Uh, so obviously creativity, it's very important. Like it might not seem like in coding it's a thing, but actually it is. Especially if you work in data modeling as such, you have to translate business requirements and business processes into data models. That requires a big amount of creativity because sometimes like the exact role of how Kimball has written his rule doesn't exactly work, so you sort of like adapt it now and come up with new solutions. So I felt like creativity is just like as important as it would be in the more artistic sort of branch of life. So in jazz, well, the harmonies that incorporate dissonance and tension to create these unique sounds are characteristic and staples of the genre. Jazz musicians often will build on the work of those who came before them, and then find new ways to create something fresh and innovative. So that's why jazz is not this just elevator music, it's evolving. You got this like really edgy kind of sound, hip hop, funk, rock, whatever you could think of. It's and it's just so rich and so creative that I feel like the parallel between analytics is like even stronger. So the simplicity in developing, testing, and deploying with DBT allow us to implement creative solutions. There is this thing in the world of musicians that the less options you have, the more creative you can be. And I felt like the simplicity, and it was mentioned in another talk before that, with the more models you get, the complexity starts to increase. So you want to like flatten that curve and make it simple. So DBT came with that solution for us. Right now, all of a sudden, there was like a simplicity framework that you could apply to create your data models, and that allows you to be creative because you have to spend obviously less time thinking other things. So we obviously, and what I'm trying to explain here is that we build different analytical use cases. So at the beginning we used it for data models, but then we start to build now specific pieces of analysis and expose them to different stakeholders, and then they can use it for the dashboards or whatever they want. And another example here is that we build here there's just two versions, but we actually built a few, maybe about 5 different variations of an SCD2, to fit different use cases. Here we go. Testing assumptions on a data set is also became a creative exercise. Now we can you come and create any kind of test you could possibly think of and just come and implement it as code and then get it run as part of your DAG. That was also a game changer for us. And we created different macros and different, execution rules and stuff like that. So now we could test for whatever we wanted and just like have it integrated as part of the orchestration in a unified way. Another component important on creativity is that, so as like if jazz musicians, they create something new and unique every time, and data analysts and and analytics engineers, you want to find creative solutions to data problems, and design these innovative pipelines, but you want to be able to use them repeatedly over time, right? Because there's like use cases that you're gonna automate and execute constantly. And in a way, like we sort of went that route also using DBT jobs, and we also created like different kind of executions with different patterns inside of it, and they will fit specific use cases and try to make it as smart as we thought it would be beneficial for us. We implemented creative solutions for managing data and deployment pipelines with DBT. So Watercare used DBT to create repeatable and scalable workflows. That was, for us, I think, one of the main visions that we had is that we wanted a resilient and scalable data warehouse. We always talk about like the data models being tight, and we always use the term of like a Rubik cube. You can slice and dice, but the integrity is always there. It's always maintained. So then the analysts could focus on other creative tasks and not just writing the orchestration for this, and just get it running, get it in DBT, run a test, see how it goes. You can always go back. The last element is structures and roles in jazz. So even though the music sounds is all over the place, it really is not. There is a lot of rules, as I mentioned before, and here is just some example of them. In jazz, you go your 12-bar blues, your 2-5-1 chord progression, your circle of fifth, your stack of fourth. There's many of the different concepts being thrown out there in music, and some of the examples that you see here at the bottom, you got the circle of fifth. So music kind of like jumps in fifths. If you go your 12 notes in the sort of Western scale, because music in the other side of the world is actually quite different to Western, and your different modes. So all of these structures and rules are in play when you are making music. So for us, that translates a little bit to the different rules that we embedded within our deployment pipelines. So we use SQL Fluff even before, a lot of people use SQL Fluff, obviously, but it was really awesome that then it came as part of DBT Cloud, but we actually embedded it within our deployment pipelines when we started the project, so it will check for these different rules, and we will enforce them, so we will try to, we were trying to achieve this consistency across all our data models to have, the same names and so you don't find a primary key here called key and in the other table is called code. Things like that. So what happened with this is that all our code looks pretty and all the code looks similar. So for self-service analytics, and if you want to encourage people to, not be scared about SQL, you want them to look at one model and then look at the other one, and it looks exactly the same. So that was our objective, and I'm pretty sure that within this room there is some people that they like the leading commas, other people that they like trailing commas. Where that's like, or caps or no caps. We enforce that, and it's funny because like people were like, why does it have to be the leading commas? I was like, well, because I like it like that, and that's what it is now. So all models have the commas there. So yeah, all code looks the same. SQL pre-commit was another one, really good. When, as part of the pipeline, then you are checking that all your models have all the YAML files completed, all of the descriptions are there, primary keys are enforced, your dimensions are called dimensions, your facts are called facts, and they sort of come together in this, like one rule and not having things all over the place. So it's good because here I'm showing something that failed, and many of them failed, even the ones that I kind of sent to production, even though I'm the one that implemented this. I still have like many of my pull requests failing because then you forget about your own rules. But it was good because then you have a unified front, everything looks the same, and then people are happy. So as I said, our focus was to ensure that these models are built with self-service in mind. So here, I guess what I'm trying to show is that, you are enforced to call your dimensions, dim underscore, your facts, fact underscore, and so on and so on. So we try to establish this pattern, and obviously it's a little bit painful at the beginning, but once you get in the groove, then, it's easy, and then you, I guess, end up appreciating that all models look quite similar. And I'm about to wrap up. This is, as before I left Watercare, the status of how the models we built. This is maybe like 30% or 40% of everything that we deploy. There's no stages, there's no snapshots and stuff like that. This is just the final kind of model, what it looked like when I sort of reverse engineered it with dbeaver. So you go customer billing, you go smart meters, you go work orders and finance GL. And the idea is that all of these models end up being, traversable. You can traverse from, customer billing to the lowest level line in the GL. And I think that we were pretty successful because we did all of this in 12 months. Now Watercare has, operational reporting ready for the big reform that's about to happen. And this is just to show some of the dashboards that we created at the end. This is for smart meters. Customer team will come and check if there is a customer that's calling over the phone and saying, hey, I've got a leak. Well, you go into the dashboard that we created and you can see live data and you can see any spike on your consumption. This is a little bit of what finance looked like. And a little bit of what work orders look like. So data models from ingestion, building all of the, all of these things with DBT, all the rules and everything, to deploying self-service models in 12 months. business consider that a big success story, and that's, I guess, what I was trying to transmit to you guys today. And just to show you finally this is to show that all of the dashboards that are across in production in Watercare, our dashboard, and this is just one of them, was actually #1 because it was so well made. People could trust the data, and obviously, if you trust the data, then you get encouraged to do more projects with this. That's it. Thank you very much for listening. Anybody's got any question? Power BI. But I love Tableau too.
Have you thought about putting in any data contracts yet?
That's a great question. I love the concept. Unfortunately, my time at Watercare is over, so I won't have the opportunity to. Thank you for that. Awesome. Thank you, team, for listening. Thank you for coming.